Hey, good morning, everyone. Everyone ready for a great event? Yes? Oh, come on, a little bit more enthusiasm, right? There's no coffee yet, right? Okay, so good morning, everyone. We're going to start this event with legacy code, right? Yeah! Good, excellent. So, my friend here, Scott, is an open source developer. He's working on the approval tests project. He's an author, and he's been giving talks about Java and legacy code for quite some time. So, put your hands together to Scott Wierschem.
Okay, so we've got all kinds of exciting things we're going to learn this week. We're going to have great new technology, new exciting stuff to check out, whiz and bang, and we're going to try it as soon as we get home, except I'm coming home to a big ball of mud. How about you? Tell me if this story sounds familiar. I work on a 20-year-old Java desktop application. It's got about 750,000 lines of code. Written by a physicist whose favorite design pattern was copy-paste. You got object-oriented programs, and those classes, they look all alike, so it does almost what I need, just copy and paste. That's what you're supposed to do. The database was really cool. It supports anything. It just connects to any other database, and it just works, because we rolled our own ORM. It's beautiful. The table control that came with swing didn't do exactly what we needed, so we have extended it so much that you don't want to change it. It's just like Excel, well, except for a couple of things. When I started there, we had no source code control. The whole application was running on the original author's laptop. If he got hit by a bus, the project was dead. Of course, no build system, but we were able to build multiple times a day if we needed to handle the whack-a-mole bugs that were constantly coming up. You fix this one and 3 pop up over here. So does anybody else work on a system like that? Come on, get a witness. Amen, brothers and sisters. I am here to tell you that there is an answer, because I also forgot to mention, we had unit tests. He brought in a contractor at one point. We had unit tests. There were just a few, and I tried them, and they didn't work. And so I fixed them. Guess what happened? Yes, everything was broken. Everything was broken. So I'm still cleaning up that mess. So what are our options when we do something like this? We can rewrite the thing from scratch, or update our resume. I'm going to provide you with an alternative that will make it possible for you to add tests to otherwise untestable code, and maybe even make it a little fun. All right? So let me introduce you to approval tests. This was written by Llewellyn Falco about 10, 12 years ago. He's been working on it mainly in .NET, but I've been making sure that the Java part also stays updated. It supports a number of languages, as you can see, even Node.js. So we're looking to the future, and Perl. So we're still supporting legacy. It's Apache licensed. It's available on GitHub. It makes it easier to do TDD and BDD. We'll get into that some. And the characterization tests, which I'll discuss a little bit later. It makes it, like I said, makes it possible to add tests to otherwise untestable code. And it's got a number of useful little tidbits in the support library that I find really handy. So let's do demo time. I want to show you how this thing works. I've got a very contrived example we'll put together. All right, I'm a hardware guy too. So you can tell this is going to be very complex. It's a we're going to create a class that uppercases strings, all right? So, where do we go? I am not Venkat, so I'm going to do my best. So I'll create a new constructor. There we go. And we will test. What is it? I'm sorry. Got to do it right. Alt-Enter. Create a test. So we have to generate. Oh, man. No pressure. Want to make. Sorry, I'm wanting it to generate the toString method. Generate missed test method. Oh, this is the test. No, this uppercase. I tried this 7 times yesterday, and it works. You want it? Oh, the class name. You're right. There we go. Create the test. No. Okay. To string. There we go. All right. Oh, yeah. So, oh, that's right. We have to do a constructor. Doggone it. Constructor. That is the constructor. And we pass in string text. There we go. toString. System out print line. Yes. All right. Sorry, I usually use NetBeans, so I'm getting all confused. Create a test. There we go. Uppercase screen text. No. Oh, come on. Are you going to do this to me? There. Here we go. Thank you. So we'll need to say text. Want to create a field. There we go. There we go. toString. Public. That's a good thing to do. All right. So now we've got our test. I want to say test, and we will say no. That's not what I want to do. So did that. So, private, public, void, test to string. How's that sound? So we'll do our uppercase string, UCS, that's a good name. Now, generally when we do this, we have our arrange, assert, and act. That's what good testers do, right? So, we will we'll create our instance of the object. That's our We'll range, we'll assert, we'll say assert, oh wait, we have to say UC, oh, we got to pass in our string. Make me upper, okay. Assert, so you say, assert equals test to string fails, and say make me upper, right, comma UCS dot to string. Oh, that's right, this is what? Test to string. Oh. That's supposed to be this. Don't you hate it when that happens? And we need that. Okay, so we got all this. So we go this and run it. And it fails. Oh, that's right, I put that new text in front of it. Okay, and then, okay, let's stop this. This is insane. This is what we run into every day, right? I'm sitting here trying to write a test. It takes me 30 minutes. I got to put the string together. It's not quite what I want. So let's do this. We'll say, we'll add to the library. Where's my library? Oh, right here. Libraries. My approval tests library. So I've got the approval test jar. And so I just say approvals.verify. I say UCS dot toString. So now if I run this, what the heck just happened there? Well, let's look at this. I have my, this is my beyond compare. So my diff tool just fired up, said, okay, this is my text, and I don't have that. What it does is it takes the name, the class that I'm running the test of, the name of the test method, and received.text. So this is what the output of the approval test was. And it's saved to this text file. And then I've got the same class method, approved.text. So if I just take that and move it to the right and save it, let's get rid of you. All right. Then I can run it again. All green, my test is done. I didn't have to figure out what that was. I just had to look and make sure that what came out was what I expected it to be. I think that's pretty cool. So, let's see. We can continue to do this. We can add tests for embedded numbers or something like that, so, or embedded spaces. So we'll have UCS2. And that has an embedded spaces there. So, because you never know, we may not work for spaces. So all I'd have to do is take this, say I want to add a system dot line separator. That's one of our favorites. Plus UCS dot UCS2 dot toString. I can run that. We very quickly fail. Throws up my diff tool. I can see that this is what I expected. That is, in fact, what I expected. So I can just take all that, move it to the right. This is hard to do with I'm zoomed in. Move it to the right, and save it. And I'm good to go. Run it again. And we are green. I could do this all day. All right? So what's cool about this? All right, so basically, all I have to do is think of a new test case. I can add it to the output. I can make sure the results are good and save that approved file, and I'm good to go. And that's all I have to do to see what sort of stuff I need to do. So what is so cool about that? Most of the time we're writing unit tests. We got this legacy system. We can't really test the whole thing, so we kind of grab some little 10-line part that we can test and sort of test for that, and we've got these cluttered all over the place. We got to figure out what was output. It takes 4 freaking evers, and I'm under a deadline. I don't know about you. I'm under a deadline. I can't get it all done in time. So here, that obviously gets hard to read. Here we just put everything into a string, save it to a text file. It verifies everything. The problems show up in the diff tool automatically. It pops up, and I'm good to go. So what if there's a bug? I mean, how are we going to find out? Well, we'll have to see if there was just some way we could figure out what the state of the object was and what changed. Oh, look, we have it right here. It's in my approved text. It's in my approved output. All I have to do is figure out what was broken. We'll go to our uppercase string. We're going to go and refactor this, so it's all better now. We run it. Oh no, something broke. I don't know what it is. Oh look, some ding-dong stuck some text in the middle. Oh, that's wrong. Now I know what to do. I know exactly where to go to fix that. So it's really, really cool. All right. So I want to encourage you to try it. I have a coworker who was very skeptical when I introduced this to our team, and he started using it and was like, "Oh, this is really cool." And he now uses it all the time as one of our best advocates for it. We don't have to have piles of asserts. We don't have to figure out the cryptic strings that we stick it in there. We don't have to reverse engineer what that might look like and all that sort of thing. So what about the legacy code? How many of you have read Michael Feather's book, Working Effectively with Legacy Code? You need to get that. I should have put a picture of that up, but that's an awesome book. In that book, he talks about characterization tests, okay? And in that, you lock down a section of code, and you get code coverage for that section of code, and then you create a test to make sure that you're covering everything in there, and then you're able to refactor that code safely. And it's really powerful, really handy. So I went to this old legacy code retreat site and found some code, so I can show you how this really works. And come on, stop that. Macs are great except for when they aren't. Okay, so here we go. We've got this this trivia game that here's our game. So it's called Ugly Trivia, and it's got a little runner, so you can see I just ran it. It runs and says, okay, these people all guessed, throwing random values in there to make sure that it worked, okay? So the first thing we need to do so we can refactor it because I don't know about you, my code looks like this at home, and I can't read it. So first I need to lock it down. So let us create a test. And create a test. This is why we like IntelliJ. Main, there we go. No, not right now. All right. And so what we'll do is we have our game runner, so we will call game runner main. I don't like this name. That's going to be dangerous, so test game. All right. So we'll say game runner. I don't know, is that static? Why? Show enough. Dot main. And we just pass no. Okay? So we run that. And it passes. Of course, we're not testing anything. So let's see what we can do here. We see that this prints out a bunch of stuff. So I'm going to show you some legacy code maintenance techniques here. So I bet that there is a system.out.println. Looks like there's a mess of them. So what I can do, system.out.println, and replace that with system.out.println. Okay, and they all get shown up. So I will create a method called system.out.println, and what it will do is system.out.println string. Pretty handy, huh? So now we can, oh, wait, I've got something not working right. Oh, we've got red stuff here. That is an object. All right, so we will do this. Object. And since we're good programmers here, oh, sorry, it's Control Shift R here. Whatever. We'll call it O. All right, but we have to say toString. Very good. So now we can run this again. And our output looks pretty much the same. Very good. So do you agree that I didn't change anything in the code there? I just made a little way for me to go in and access it. That's called a seam. That's what, what's his name, the guy who wrote that book? Michael Feathers wrote about, is creating a seam. So this is a way for me to sneak in and start testing this. So now, what I'll do, I want to take these print lines, and what I'd like to do is log those to a file or put them in a string so I can stick an approval test in there. So this is one of the cool things that approval test lets us do. So we, I see, I think I've got approval tests in the library already. Let me make sure here. In the libraries, we have approval tests. Good. So, all right. So now we add. This is one of the features for this this tool here for system out. So we'll do. Come on. So it's simple logger. And we'll just say, right, so simple logger dot message, and we'll do o dot toString. Okay, we can run that. And we see now we've got one that does a log with a timestamp and one that logs out. Okay, so we're getting there. So what we'll do is now we will take this, use this as a characterization test. So now we'll go back to our test, and here we will say simple logger dot log to string. Okay, and we'll go ahead and introduce a log variable. Okay, and then I can just go here and say approvals dot verify log. Okay, let's import that class. Good. Now we run it. And that's pretty cool. So I've got all my output automatically going to this, this file because approval tests know how to manage all that stuff. It's magic. So I'll just copy that on over and I'll save it. And let's try it again. And it failed. Oh, looks like they've got some, they've got the random number stuff. So let's do some more magic here. So we'll go to Game Runner. So they've got this random thing here, random, new random, and they use this rand for when it's running its game. So let's do this. We'll go and select all this, and extract a new method. We'll call this main2. I'm very creative with my names. All right, so I used the built-in refactoring tools of JUnit. I have not changed anything, right? So it still works. I still have all the same bugs I had before, except now I call main2. So what I can now do is take this random and pass it in as a parameter. Random, rand. Take that. Okay, do you see what I just did there? I created a seam where now I'm able to control what I'm testing. I've passed in this random value because it doesn't matter where it gets initialized up here. So basically that's at the beginning. I can pass that in as a parameter. Now I can call main2 and I've got complete control over how I do this. So I go to my test and I call main2 and I say new random 0. That's a nice one. And what's the matter here? Oh, right. Come on. Game Runner. Yes, that was in my notes. I wasn't checking that. Public. So we do here. We run our test. It throws up beyond compare. Things are different. I'll just select everything, move it over, save it, and let's try it one more time. And if we've covered everything, then we should get green. We got green. So we now have made sure that it's going to give us the same results every time. Now we have to worry, do we do code coverage? So let's run this with code coverage. And code coverage. What is this? I've never seen that before. Yeah, fine. All right, so we've got like 50% of the, what is this? Of the runner. Okay, well, I want to test more than the runner. So what I do is I come in here and I say, edit configurations, and I will code coverage. I will add my game in there as well. Boom. Okay. So now we do our code coverage test. We see that the game runner, that's covered, except for the main, which we're not calling anyway. We go to the game, and that's all covered, except for this here, is playable. And it's never used. So it's okay that we don't cover that. But otherwise, we have covered all of the code. Well, that's pretty handy. So now I've got complete coverage of the code, and I can go in there and safely refactor this code. So now think about this. Think about this. Do you know how that code works? Do you know anything about what's inside that application? No, but we have complete code coverage, and we are confident that any changes we make will be caught by the testing tool. I don't know about you. That has changed my life. It is so freaking powerful. So there's all kinds of, like that simple logger, there's all kinds of little secrets hidden in that support library. I'm going to start putting together some training videos to show off some of this stuff and start documenting it, because that's one of the problems with most open source products, is that they're not very well documented. So I'm working on improving that documentation. If you have any questions about it, you can ask me. Now, one of the cool things that it'll do, like if you've got a 2x2 matrix array, whatever, that you want to look at, the whole point of using the approval test is it generates that text file that's easy to read, so you can quickly glance through it and make sure that the output is what you expect. So you might need to do some formatting. He's got all kinds of little formatting goodies in there. One will go and display a 2x2 matrix as a 2x2 matrix. So you can do your little checkerboard or tic-tac-toe board or whatever. He's got an example where he does it with a tic-tac-toe board. It's really handy. His example with the tic-tac-toe board also will generate every possible combination of moves for tic-tac-toe. That's pretty cool. So it's nice to have all that in one tool where it'll generate all your examples. And it's got a lot of other stuff. It will even verify a user interface. Let's say you've got a web application and you want to verify any changes to the user interface. That's like the bane of software developers, right? Spit out your web page to a text file, and you got it. You can run it through approval test. You can quickly see if anything has changed in that. That's pretty cool. It'll even, like I said, I've got a desktop Java app. That means swing. So we generate a swing image. It will go, whatever, swing window. It'll go take a picture of that virtually, save it to a .png file, and then if you've got an image diff tool, it will go and fire that up, and you can see the differences between the images. Let's see, do I have time to show that off? I might in a couple minutes. But it's really, let me go ahead and show you that. I think it's really cool. I like to show it off. Do we have any other swing people here who would be interested in that? Okay, good. I like you legacy people. So let's, where is that? I think it's called Hangman. Boom. So check this out. This is just all done. Hangman test. So basically Hangman, it's just a regular Hangman game. So my test, if I run that, So you saw it drew the little swing picture for you. Now I've got P4 merge, which is a visual image differ. Okay, so what I did is I put together a picture using Paint or whatever the equivalent is here on the Mac, and said this is what I want it to look like, and then this is what the layout ended up being like. So I could use this as a BDD tool. So this is what I want it to look like, and then I start coding towards what I want it to look like. But then, you know, if you get it'll automatically throw up this image. I think that's super awesome, super cool. You can, yeah, like I said, if you're going to do BDD, you just figure out what you want your output to look like, and you code to that. And I think if you try it, you'll like it. Now, there's a couple of limitations. If you're using this here, and you're using on Windows, you're using like rounded fonts or softened fonts, I think that's called, and your build server, if you've got this in your automated build server, oh yeah, that's the other thing. You take that approved file, you check that in with the rest of your code, your automated build, then that automatically gets checked just like any other test, and it doesn't take up that much more space. It's so cool. I forget what I was going to say. Oh yeah, if your build server doesn't have rounded fonts, then it'll notice the little gray in the corners of the fonts, and things will be different. So you can figure out a solution to that. Right now, it doesn't have Maven support. We're working on that. I think we're waiting on Maven Central to approve it. I'm putting together, like I said, some training videos for using this with Java and lots of other goodies. We also, if you want to use this, we have katas. So if you're wanting to learn how to use it, if you go on the GitHub page, there's javaapprovals.katas, and you can run through those, and it basically gives you little puzzles to solve. So you can figure out how to get it working with that. And if you want to know any other stuff, please don't hesitate to ask. And pretty much that's what I have to say. Now, I have my blog, keepcalm&refactor.com, where I like to talk about legacy code stuff. And I've got an ebook, The 7 Deadly Sins of Software Development. The first sin is no testing. So if you go there, you can get my free ebook. And really, that's all I have to say about that. Does anyone have any questions? Yes, sir. I have not tried it with JavaFX. I should, but I have no reason to believe it would operate any differently. Yes. Okay. Wow, you're moving to the future. I'm impressed. Right. Anything else? Yes, sir. Yes. Okay, well, we've been working on it for, he was asking about what is Maven support and when do we expect that to be in there. We've been working on it for probably a month or so. There's some aspects of it that are kind of difficult. There's someone else who's working on that part. And I don't know if that's already been turned into Maven Central. So it's probably on the order of months. So basically, I don't know, with Maven, it is possible to sort of hack in a local copy of a library. And I'm sorry, that's what you got to do for now. But he works on this in .NET. I'm the Java guy. So, yes, sir.
Whenever adopting new libraries, I always try to ask myself, is the cure worse than the disease?
Yeah.
And here, what is the disease that we're trying to solve that vanilla JUnit doesn't give us?
Okay, what this solves that vanilla JUnit does not give us is that you don't have to go and write special, whenever you're doing an assertion, you have to figure out what the answer is going to be and put together a string that looks like that, and that tends to be a cluttered up pile of mess. And at least for me, that always tends to take a lot longer than it's worth, and I get really frustrated putting that together, and I usually screw it up, and then the tests get out of sync. So the approvals just make it easy to add a test, add a test, add a test, add a test. I'm good to go. This looks good. It's a legacy system anyway. The tests aren't really all that good anyway. We're hopefully going to be refactoring this stuff and making most of that ugly stuff go away anyway. So just getting it done quickly helps me to move forward a lot more quickly. In addition, you got the ability to check images. If you want to check your HTML, I could save it to a file and then fire up the previous version and the current version in my diff tool, but this does it for me automatically. That's just anything that'll save me some time, I'm all for it. Does that answer your question?
Mostly, yes. I'm not sure. I've never worked with a legacy product and percentage of it work like that. You probably do, but I'm not sure. I think I'm in a situation where asserts are just cluttering my test, mocking that.
Yeah. You're a fortunate man. The rest of us have had to fight with legacy nonsense. Well, a lot of us have had to fight with the legacy nonsense a lot of times. Anyone else? Anything? Yes, sir. Will this work for integration tests or end-to-end tests as well? I guess that depends on how you want to use it. Like I said, you can put it into your automated build tool if you're running a series of tests. It runs very quickly, you saw. It should work. I don't know. It's kind of at a granular level. So for your integration tests, it might be, a little bit too in the weeds, but otherwise, yeah, I use it. I find all kinds of uses for it every day, and I like to go digging through that library and say, I didn't know you had this in here. This is really cool. So, yes, sir. It does not do type-based assertions, no. So basically, it stuffs things into a string. What you might do is, do a type of thing or get the class and stringify that and that sort of thing if that's something you need to test. So, yes.
So after we've written the applicable test to the refactor list, do we keep the applicable test?
After you do the refactoring? If the approval test is still testing something useful, yes, there's no reason to take it out. It doesn't slow things down, because otherwise you'll have to put some other kind of test in there. But generally, when we're refactoring something, you've taken something that's hideous, like this game program, and you've pretty much made all the ugliness go away. You've put in other tests that are more useful, or you're just wanting to make sure that it continues to work the way that it used to, so you can just leave it there. That is tested. Well, I get hollered at for spending too much time writing tests. I don't know about y'all, because I'm supposed to be writing code, doggone it. That's what I'm paid to do. So, yeah, if you've got an approval test that you can put together quickly and it gets you up and running and it continues to work after you've refactored it, there's really no reason to take it out. Okay? Anything else? So, again, like I said, it was written for .NET. There's some extra goodies in there for .NET. If you go on Pluralsight, there's a set of videos to teach you how to use it in .NET. But if you go on YouTube soon enough through my site, you'll have some links. And if you go to the approval test site, there's videos and information about there as well. So I thank you all for coming. I hope this was useful, and I hope you find this a very useful tool.